Due to its 12th anniversary, Denafrips has issued an upgraded version of the Ares DAC, the 12th. I looked at the current -1 version. I discovered Denafrips only 3 years ago and reviewed the Ares 2 and almost all other models at the time. They all had and still have the same topology, an FPGA processor controlled ladder converter with oversampling that can be switched in or out, a linear power supply using an O-core transformer, no volume control and no remote control. New is that now also an I2S input is added. Up till now only the upmarket models had this. Denafrips also introduced a streamer in matching chassis and colors that I will review soon. The Ares 12-1 is to be connected to an amplifier over RCA or XLR cables depending on the amp. And the amp needs a pair of loudspeakers or headphones connected to it. Let's go for loudspeakers. A DAC also needs a digital source. In this streaming era we go for a network bridge or streamer connected to the DAC over either SPDIF, Toslink, USB or I2S. It is also possible to connect a computer, laptop, tablet or phone directly to the DAC over USB. But the bridge or streamer will normally give the better result. In this case the bridge is connected to the router over Wi-Fi or network cable to give it access to streaming services and internet radio. Music on the computer can also be played back. The bridge needs a server program on the computer like Amara or Ivana, J-River Media Center, Logitech Media Server or Roon. Those programs are mostly controlled over a tablet or smartphone. A CD player can also be digitally connected over for instance SPDIF to the DAC to improve the sound quality of CD playing. The same goes for the digital output on your TV. Here the optical Toslink connection is used, not HDMI. The I2S HDMI input is not compatible with HDMI on your TV. Do make sure that the digital output of your TV is set to stereo PCM and not to Dolby Digital. The Ares 12-1 now has an all aluminium chassis galvanized in silver or black. It measures 215 by 230 by 45 mm and now weighs 3.5 kilograms. On the front left we see the standby button with above it the tiny LED that signals the standby status. There are 7 buttons on the front, 4 of them for choosing an input: USB, SPDIF called coax, Toslink called opt and I2S. Then further to the right a button to switch oversampling on or off, to reverse polarity called phase in good high-end tradition, and finally a mute button that doubles as a setup button. Left along the top in the well-known Denafrips tradition LEDs that indicate the base sampling frequency for PCM 44.1 or 48 kHz or for DSD64, plus multiplier LEDs. For instance, for 192 kHz PCM, the 48 kHz and the 4x LEDs are on. Further to the right 4 LEDs that indicate the selected input and LEDs to indicate if oversampling, phase and or mute are engaged. On the rear we see the IC mains inlet that, after unpacking, has a sticker on it warning to check if the voltage selector on the bottom is set to your local grid voltage. Next to it the digital inputs: USB, I2S, Toslink and SPDIF. The I2S input uses the PS audio pin out, which can be changed in the setup. Again here a sticker warning that this I2S port uses an HDMI connector but should never be connected to a normal HDMI connector from your TV or AV receiver. The HDMI cable is used since it is a wideband multicore cable and connector and therefore also ideal for I2S digital audio connections where the serial clock, word clock and serial data are sent over 3 pairs of cores plus ground. Then the analog outputs that are available single-ended 2.11 volts on RCA and balanced 4.22 volts on XLR. If your amp has XLR inputs, use these. Never use both XLR and RCA outputs at the same time. When the lid is removed, the thick aluminium side and front panels are clearly visible. Directly behind the IC mains inlet we see the small circuit board that holds the fuse. Mounted on the same board from the rear is the earlier mentioned mains voltage selector pointing down to a hole in the bottom. From there the AC voltage goes to the in-house made Denafrips O-core transformer that in turn feeds the now lower AC voltage to the rectifiers that turn AC into DC and the electrolytic capacitors that do the buffering. Directly mounted behind the digital inputs we find a small circuit board that does the USB interfacing using the STM32F446 advanced AMR based microcontroller. It is switched off when the USB input is not in use to prevent interference. Below this circuit board the SPDIF, Toslink and I2S input circuits, where the Altera Cyclone 4 FPGA handles these inputs and drives all these ICs around the resistor banks that switch on and off in total 480 precision thin film resistors that form the ladder converters. A pair of analog devices op amps buffer the output. Daily operation is rather simple. Connect your source, switch on the source and the DAC, select the input and you're ready to go. Windows users need to download the Thesicon driver to use higher sampling rates over USB. Linux and macOS users don't need a driver. SPDIF and Toslink inputs support up to 192 kHz 24-bit PCM and DSD64. USB and I2S support PCM up to 1536 kHz 24 bits and native DSD 1024. You can have the oversampling switch on or off. When on, you can select either a slow or fast filter by pressing the mute button for 5 seconds and then toggle between the two with the opt button. I'm missing the point of upsampling. Using a ladder converter is especially attractive since no signal processing is done. But you have the choice. The I2S input defaults to the PS audio standard. 6 other pinout variants can be set in a similar way as the filters. Not the most transparent method, but luckily the PS audio pinout is mostly used and once set there is no need to ever change it again. And the manual contains a link to a video instruction on YouTube. In good Denafrips tradition there's no volume control, no remote control and no automatic input switching. R2R converters work by using an array of resistors where each resistor is half the value of the preceding one. Like every lower bit presents half the value of the preceding one. By combining resistors and thus bits, every resistance value can be achieved and thus output voltage. But that works to a point where the resistor values become so low that accurate values no longer can be achieved. In this table you can see that when all 24 bits are high and thus all resistors are in parallel, the output normally is the Redbook spec 2 volts on single-ended outputs. If the most significant bit, the number 1, is high, 1 volt is output. When we look at the output voltage when only bit 22 in this 24-bit system is active, we see that 0.40 microvolts should be output. In practice this is not achievable given the thermal noise in resistors. 19 to 20 bits resolution is the max. Low bit converters work differently. They use upsamplers to calculate in-between values at a higher sampling rate and the lower bit depth. This is comparable to DSD where only 1 bit is used. But the dynamic range in digital systems is 6 dB per bit used. Using 1 bit therefore means a dynamic range of 6 dB. By using a technique called noise shaping, This noise is moved outside the audio band and then filtered out. But it also means that you need a very high sampling rate. DSD uses a 64-volt sampling rate compared to CD. As a result, the precision as needed in the ladder converters is no problem since there's only one bit. But it also means that the precision of the clock now is far more critical. And the upsampling algorithm now has impact on the sound quality. The filters used in these algorithms can severely cause time smearing, and especially with 1-bit converters, noise modulation will occur and that reduces the perceived resolution. Therefore many DAC chip manufacturers use an in-between solution, somewhere between 2 and 5 bits. Affordable low-bit converters have limited processing power and as a result will have time smearing due to simple algorithms. In practice it boils down to this. Ladder converters need no digital processing, but it's difficult to achieve 20-bit resolution or better. Low-bit converters do need digital processing. Nowadays they can achieve a 1 or 2-bit higher resolution, but in the affordable class will have some or more time smearing. On the Ares on review here, there also is an upsampler integrated and it can convert DSD. What can you do with this knowledge? Well, listen to both types of DACs and choose the one that you think sounds best. Or, differently put, choose the one of which the artifacts bother you the least. In both cases you'll find that the digital to analog conversion has improved considerably over the last decade. In my reference setup 2, the Ares 12-1 was connected to the Marantz PMKI Pearl Lite over Siltec London RCAs. It drives the Acoustic Energy Radiance 1 loudspeakers connected over Kimber 4PR loudspeaker cable and supported by the Rel T5 subwoofer that is connected to the loudspeaker terminals on the Marantz using the cable that came with the sub. As a digital source, the Magna Mano MK3 Fired streamer running Rupee was connected to the Denafrips over a short 4K HDMI cable using the I2S interface. From there a Cat6 patch cable connected to the Opton Audio Ether Regen switch with Opton Audio UltraCap's 1.2 power supply. The fiber connection runs to the Netgear ProSafe GS418 TPP switch, also on the 3rd floor. There the Intel NUC 10i7 FNH was situated that runs on rock on an M.2 SSD and has the music stored on an internal Samsung 8TB SSD. See About My Reference Setup May 2023 for more information. Links at the usual places. Roon was controlled using an iPad Pro 2 and the equipment was placed in a target rack. The Ares 12-1 sounds rather neutral with a nice stereo image. Focusing is good with a fair amount of air around the instruments. Sibilance is rather good controlled and resolution in the mids and highs as to be expected from a good ladder converter in this price category. Lows are a bit rounded and poor in texture. The biggest merit is that it's easy on the ear and doesn't fatigue. I rate the Denafrips 12-1 in the low end of my setup 1B. The Ares 12-1 is a slightly upgraded version of the Ares 2 I reviewed in September 2000 and that now is rebranded to Enyo. The biggest difference is the now full aluminium chassis that is very sturdy and looks clearly more luxurious. It is also in line with the Ars streamer that Denafrips recently introduced and I will review soon. It also has the I2S input to connect the I2S output on the Ars. It lost the second SPDIF and Toslink inputs, but very few will miss that. The distributor Vinshine by the person of Alvin has a very good instruction video on YouTube on how to change settings and other support items. Remains to tell you the price. €1,064 including 21% VAT. Which brings us to the end of this video. See you next week, Friday at 5 PM Central European Time. If you don't want to miss that, subscribe to this channel or Follow me on Facebook so you will be informed when new videos are added. Help me reach even more people by giving this video a thumb up or link to this video on the social media. It is much appreciated. Many thanks to those viewers that support this channel financially, especially in these times. It keeps me independent and lets me improve the channel further. If that makes you feel like supporting my work too, the links are in the comments below this video on YouTube. I am Hans Beekhuizen. Thank you for watching and see you next week. Whatever you do, enjoy the music.